Welcome to The Router, the official podcast of the UQ Computing Society, where we explore the human side of tech. I'm your host, Matt, and today I'll be having a chat with Samual MacDonald from Max Kelsen, here to talk about working in machine learning and data science in Brisbane. All right, Samuel. Firstly, could you introduce yourself and your background?
Okay. My name is Samual MacDonald. I'm a machine learning researcher, I suppose. That title seems to always be changing, I think, because of the fluid nature of the work. My background in, I suppose, reverse order is being a researcher at Max Kelsen, and then a Master of Data Science student at UQ. And then before that, I was an environmental and engineering geophysicist. Before that, I was a geotechnical engineer. Before that, I was a uni bum. And before that, I was a house painter. And so that's my background, I suppose. Back to 18.
And I guess, so you spent, I guess, 1 or 2 years doing your Master of Data Science?
Yeah,
so,
yes. I actually took 3 years to do that because by the time I'd started, I think I was about 26, and I think that's mature age student, and had a few life experiences that made me realize, I suppose, what employers are looking for. I think if they look at your CV, they'll look at grades. Of course, there's sort of like an easy filter to shortlist, but the final decision doesn't depend on grades. I think they also look at how long you take to complete your degree. They look at your experiences, and I think they use your experiences. Thirdly, the experiences as the most important final factor that ends up deciding whether or not you'll get the work. So with that in mind, like thinking about uni as optimizing 3 things: grades, speed, and experiences on top of grades and how fast you complete it. I decided to take it over 3 years.
Yep.
That would allow myself more time to do other work and because I figured if over 3 years I had all this spare time to do all this extra work, I'd come out at the end with a lot more experience than the people I'm competing against. And so, yeah, I don't know if I'm talking about a different answer to a different question.
No, I mean, no, that's good. So I guess your university experience, you mentioned you had you did quite a bit of work and stuff during your university time. What was it like doing classes after working for so long?
It was at that point I'd worked for 3 years in a very competitive private firm, and so I was used to big hours. So my undergrad was tough. You know, doing an engineering. My first degree was in civil engineering, and that was, I found, very tough compared to high school. High school, I didn't remember doing anything really, just floated on through and got, you know, a grade good enough to get into an engineering degree. It was very much focused on things other than work and career at that point in my life. It was only through my first degree that I started to get career focused. And so, yeah, I think I found that was really tough. But then when I went into the real world and started working, that was very, very challenging. And I think you'll end up doing, you know, the odd week where you're doing like up to 70 or maybe even 80 hours. The odd shift where you would have to do a 20-hour shift or something. And that was very intense. It wasn't always like that. It wasn't like Apple back in the day or whatever, where they consistently do 75 hours. But I think there's a lot of companies that do still do that. And I think 3 years of experience of working really hard like that made doing a master's quite easy. I remember the Masters of Data Science, even though I was learning a lot of new things about statistics and computer science, quite challenging. I remember that being a breeze compared to the industry, and so actually it felt quite relaxing, working a lot and studying a lot in comparison. And so it was just contrast relative.
Yeah, fair enough. I imagine even as a uni student, I've never done anything close to 75, 80-hour weeks before. So I guess.
But that's different. You wouldn't be able to because it's a different thing. As a uni student, you're learning. And learning is such a different mode for the brain than it is doing work that's not requiring learning, as much learning anyway. The first year of work you'll find really hard. I think the first year of uni is really hard because of all the changes. But I think the first year of any degree is the hardest for a person coming out of high school, on average, maybe.
So when you started working at Max Kelsen, was there anything that your university experience didn't really prepare you for, or that you weren't expecting?
I think, in for the Master of Data Science, I was in the first cohort for that.
Yeah.
And I think even the label data scientist, I think even still now isn't really consistently defined. And so I think that the Master of Data Science did really, really well in preparing myself for a lot of different things, and it had the flexibility for me to home in on the particular areas that I was interested in. For example, I chose to focus more on statistics than database type subjects, but I did do a few database type subjects. I think I did the data mining, a couple of subjects that were specifically focused on database principles, and then there was a big data type analytics subject, and I felt like those subjects didn't prepare students well in what I think is involved in working with big data. That's not something I'm particularly focused on at work. There are people at Max Kelsen that do focus on data engineering and ML ops, which is like taking everything to production. But I think that the UQ data science program, and I think the same can be said for computer science and software engineering more broadly, having looked at all the subjects. In my own opinion, from what I saw, they weren't up to date on what's being done now. But I do know that UQ are working with organizations such as Amazon Web Services, AWS, and I think they're sort of helping them catch up.
I see. And I guess, do you know any good resources to fill the gaps for the things that you didn't pick up from university? Or was it sort of just like in your area of work, you didn't really need to?
I think the only way is to learn on the job. I think you can try and prepare yourself with terminology by getting a few certifications and stuff. I think Amazon is great for that. And I think Google is great for that also. So those certifications are something that everyone is getting to put on their CV to make themselves look more attractive. Those certs, I think, in and themselves probably aren't enough to be a reliable data engineer or anything. But I think they will help in being aware of what are the common modern methods and what is all the terminology. And then I think it's really just about learning on the job, and the other big thing I think that's missing from any degree is just real world experiences. Like, how do you interact with people? There's a big difference between between doing a group project and actually working in a company where there's the complex politics and client demands that are ever changing. And then, how do you interact with your supervisor? How do you know when to ask a question and when not to ask a question? For that's the common thing I think people fail at. I think it's important to, if you have a problem, come up with a list of solutions that you think and come up with 5 different ways of answering the problem, even if they're all wrong, and then go to your manager or supervisor with that rather than just a question. It helps them prepare their mind to give you a better answer, but it also just shows that you're just doing your absolute best. Yep.
I see. So I guess as you started like working in machine learning research or that sort of area, a lot of students choose to focus on one or both of computer science or statistics in their undergraduate degree to try to like prepare themselves for that sort of work. What do you believe is more important between those two?
Between statistics and computer science?
Yeah.
I think computer science sort of subsumes statistics, that statistics is very much a part of it. And I think very much that people always say, like, and it also, this depends on what you define as machine learning and statistics and computer science. And it also depends on where you're at and where you want to go. For me, I got very interested in the statistics because of my geophysics background sort of gave me interest there. And I think civil engineering is more of a statistics focused engineering branch compared to something like mechanical engineering where you can rely on first principles a bit more directly. So I think I got very interested in statistics, and then I found the deep learning book by Ian Goodfellow and Yoshua Bengio. And I read through that because I got absolutely obsessed with the concept of deep learning. I found it very interesting. And so that, I think, put me in a position that had me more attracted to the more mathematical perspectives compared to the more, programmatic perspectives. I think if you, so that's like my personal setup of, I suppose, I've just relabeled it as between a more mathematical approach and a more programmatic approach, compared to a more statistical approach versus a more computer science. So that's like the terminology I'm sticking with to answer this question. It's a hard question to answer. And I've also framed where I was positioned when I made the decision of which I'd pursue, then which to the only thing remaining is like which to actually pursue. And I think ultimately everyone will have to focus on both.
Yeah.
And I think it depends on where you want to go. For me, I wanted to go into more research. I wanted to learn more about how it all works and what are the possibilities, what are the limitations. Because if you understand the possibilities and limitations, you can reason about the safety and the fairness, the reliability of it, and talk more about and help prepare people for realize the follow-on technology. But I think everyone should try and be aware of the limitations of it. And I think if you're going to be aware of the limitations of it, you have to be aware of the mathematical perspectives. And so I think everyone has to do the basic statistics, and everyone has to try and understand as much as they reasonably can. So then, and it also depends on your personality as well. So then the programmatic perspective, I suppose you'd want to pursue that if you're more about seeing something that's getting some sort of an output. If you want to actually be at the edge of in the industry, if you want to do consulting, you very much want to get very good at being fast at just programming something, knowing how to work with AutoML, knowing how to do all the pre-processing, and knowing how to just quickly benchmark and iterate over all the different models and learn about the tuning of the hyperparameters on a very black box perspective. And I think you can go very, very far by knowing very little about the mathematics. And then, but if you take that road, you'll find yourself more in the operations side of things, and you'll find yourself very much focusing on data engineering problems and putting things into production. So it depends on what your strengths are and what you're interested in.
I see. So I guess, yeah, it depends. Fair enough.
That's yeah, it's so complicated, I guess. And I'm terrible at giving simple answers to complicated questions.
That's all right, yeah. It is a complicated topic, and I guess it seems like the best thing to do is just, get comfortable with both sorts of approaches. Yeah.
I suppose the easy answer is a cliche, and that's just you've got to do both. You have to.
Yeah.
If you just do the mathematics, you're not going to get far at all. If you just do the programmatics, I don't know if that's a word. If you just do the programming, you're not going to get very far at all. Try and do both, and then decide on what you want to do more of by how you enjoy it. Just do what you want to do, and what you think you like, and don't. I guess you don't have to make it complicated. That's what I did. Like when I decided to learn more about the mathematical perspectives, I just enjoyed that more, and so I just did it. It was that simple.
Fair enough. I guess I sort of want to pivot more to like your work life now. One thing I'm curious about, what's sort of like a typical day at Max Kelsen? What's that sort of like?
And I think I've been at Max Kelsen almost 2 years now, and it feels like every month the company has changed so much. It's there's a whole bunch of different new people, and the way we work is very different. So I guess there is no typical day, like it's always changing. That's the amazing thing about data science and machine learning, that you'll always be working on different types of problems, probably working with different personalities, very different personalities. That's something I really like, that there's a lot of different sort of characters, and but it's for me, I work mostly in research, and so it can be with looking into say genomic information and trying to answer questions about cancer, or it could be in doing blue sky research into Bayesian deep learning and learning how to ascertain uncertainty. That's like my key interest. And then sometimes it could be just like popping in and talking to some other companies about how we can work together and how we can provide AI and ML services to assist them. In the consulting side of things, so there's two main groups of Max Kelsen. There's the consulting, and then there's the research. I work in the research. In the consulting, it's a very different game. It's very time focused, very intense, fast work, and that's more about the problems can just be so diverse. They can be about ordering pizzas, or it could be helping in healthcare, whether it's visualizing various diseases, or whether it is estimating how long a patient's going to be in intensive care for, or whether it is does a surgeon have all the equipment available to do their work, or and every single, there's just like so many different, there's insurance, and then there's so many different types of problems, and just all of them are just very, very different. But usually it's just like working with a team, and and just every day feels different. I don't know. I can't say what a difficult day is.
That's so good.
That's
Could you go a bit more into detail about like your area of research?
Yeah. So, are you more interested in the genomics or in the Bayesian deep learning?
I
Yeah,
guess both. They're both big like areas that you're interested in, right?
mm,
Genomics and
the two groups I work with most are, so in the research team, there's like we all sort of um, uh, uh, work in every area a little bit where we can, to keep things flexible and moving. There's three main groups in the research team. There's uh, the interpretable AI group. That's where I mostly work, and then there's the genomics group. I work there a lot too, and then there's the quantum group. So I can only really speak for the genomics and the interpretable AI. Interpretable AI is more about, okay, we've got this all these new algorithms that are becoming very powerful because of the advent of GPUs and computing around big data. So now we've got the possibility of learning from large amounts of data. So deep learning is becoming a thing, and but the problem is that it's got this amazing predictive power, but it's not. We can't really rely on it. We don't know when it's going to work, when it's not going to work, and we don't know if, without true labels, we don't know when it is working and when it isn't working reliably. And so that's what motivates the use of uncertainty, or the modeling of uncertainty. And then so in interpretable AI, we focus on modeling uncertainty. We focus on explaining which features or which inputs are contributing the most to the decision of a neural network, and then also we're starting to scratch on the surface of causality in that group too. And then that group sort of helps service other areas of Max Kelsen, including genomics, who use a lot of methods from interpretable AI also. In the genomics group, we work to solve problems about immunotherapy outcome prediction. So if you're given some genomic information, can we predict whether a patient will respond positively to some treatment? And then there's problems about cancer of unknown primary, which I think is very difficult to treat if you have a cancer of an unknown primary, and I think can attribute to about 5% of people who die with cancer, I think. And then in the genomics group, there's a bunch of other things that go away from cancer genomics. We're interested in agriculture. We're interested in the Great Barrier Reef and coral, and I think there's also Maciek, the research lead, has a big background in psychiatric genomics. He's sort of the in-house genomics guru, and then. So that's sort of, it's that space there that I've just described, where I spend about 90% of my time. And that's Kelsen.
I see. Okay. Yeah. I guess this is a bit more of a broader question. So these sorts of machine learning solutions, I guess if you read like the news, or if you read if you just Google machine learning and things like that, you'll find a lot of things about how it's the solution to everything, like it can solve every single problem. And are there any problems that those sorts of approaches don't really work for, and other sorts of problems that are that machine learning approaches are better suited to solve than others?
Yeah, I hope I can answer this question. I think, as you'll very well know, machine learning has its limitations, in that it's very good if you have a very specific, well-defined task that is non-stationary. And so if you and beyond that, it's completely unreliable and useless. Whereas more traditional engineering disciplines would work on using physics to simulate some sort of a system and be able to make inference about the future or various scenarios that the system can be put through. And those sort of more physics-based methods are very reliable in comparison to machine learning. So yeah, I think if you've got a well-defined task and if it's narrow, machine learning is very good. But there's lots of narrow tasks that can be well-defined. And so machine learning is being found everywhere. The biggest problem, in my opinion, of machine learning in general is that it will bias what it is experienced on, just like everyone does. And so, for example, if it's trying to predict between a cat and a dog, and 99% of the data points that it trains on is a dog, it will commonly say a cat is a dog. And because the classes labels are imbalanced. And that's all fine because we can just balance. There's very easy ways to deal with that problem. But the concerning thing is that often with tasks, there are hidden variables. For example, if you're looking at genomic data and you're trying to predict, let's just use the example at Max Kelsen. If you're trying to predict immunotherapy outcome, and you're using genomic information, if 90% of the genomic information comes from Caucasian men, then it will be unfair on Black women or any minority group, or more generally any underrepresented subpopulation. And so it can be unfair against those people. And that's a really important thing when you think about where all the data is coming from. And it's a really important thing for fairness. And it's a really big shame, I suppose, that it's starting to be used everywhere. And a lot of groups, not just racial or gender groups, but just any kind of subpopulation you can think of that is underrepresented will be unfairly discriminated against.
And I guess that means the data set size and the way that the data set is collected is really important to have these solutions.
Certainly, yeah. That's one way around it. There's other ways around it. Yeah, but I'm not going to even start talking about that.
That's so good. I think you've given a really good overview of everything, and I guess like the uni experience up to work, and also I guess a few specifics about research, which I found really cool. That's pretty much all the questions from me. Did you have anything you wanted to say?
Oh, just thanks very much.
Thank you for coming along.
Yeah, it's a pleasure. It's really awesome that you're doing this podcast. I think it's really cool. I hope I could be help to anyone at all.
Certainly.
Yeah, cool.
All right. Thanks so much.
Thank you, Matthew.
That's all we have for you today. We hope you'll join us in 2 weeks for the next episode of The Router. And until then, come join our community at slack.uqcs.org.